Hello everyone, welcome to my next video. In the last video I show you how to make a graph of trigonometric function, and we took y equal to sine x and we plotted graph for this function. All right, and I also mentioned how to find the amplitude of the function from the graph. Okay, all right, so I will draw that again. So what is the graph we got for this function y equal to sine x from my last video? It's like that. Slightly, I drew slightly bigger actually. Okay, that's fine. So 0, that's pi, and then that would be 2 pi. Okay, and that's pi over 2, and that's over 3 pi over 2. So that's how we draw the graph in our last video, and that's 1 of course, and that's minus 1 of course. And we figure out what is the amplitude of this graph. Amplitude of this graph is maximum value, which is 1, right? And difference of maximum and minimum value of this function is minus 1 divided by 2, so which is 2 over 2, which is 1. All right, so this is the graph whose amplitude is 1. And also if you see the equation y equal to sine x, how to find the amplitude from the equation itself, just see here y equal to a sine bx minus c. So this is our general equation for any trigonometric function. For sine and cos, this is valid. So since this is sine function, so I wrote sine there. If it is cos function, I will write cos there. And then we compare this equation with the general equation. What do you think? What is the value of a we have here? 1, right? That a basically represents the amplitude. So you can also figure out what is the amplitude of a trigonometric function from the equation itself. From the equation itself without drawing the graph. All right, so there are two ways to find amplitude. And now I will show you how to draw the trigonometric function when the amplitude is increasing. So if you see, let us see if our given function is y equal to 2 sine x, then how to draw its graph. Now what is the amplitude of this graph if you compare this one again with the general equation y equal to a sine bx minus c. So here value of a is 2, it means its amplitude is 2. So how to draw the graph? So what you have to do, we have to do nothing but so easy now. Whatever be the y value in y equal to 1 sine x in the original graph or the basic graph, this we consider as a basic graph, multiply all the y values by 2. All right. So if you remember the table of this graph, I will make that again so that you can easily see what I'm gonna do. So in the last example, we did x, y, right? So when x is 0, we got y is 0, right? Yeah. And when you got x is 90 degree or pi over 2, you can say it is 1. And when we figure out when x is 180 degree, it is 0 again, right? And then we figure out when x is 270, it's minus 1. And when x is 360, it is 0 again. So these are the y values we have for our basic graph y equal to 1 sine x. Now to draw the graph of y equal to 2 sine x, all we need to do just multiply all the y values by 2. So that's how you can draw the graph of trigonometric function sine and cos both when their amplitude is changed but not the period, and there's no change in the phase shift as well. Just the period is changing, okay? Oh, sorry, just the amplitude is changing. All right, so let's multiply all the y values by 2 because our function is y equal to 2 sine x. So 0 times 2 is again 0, 1 times 2 is 2, 0 times 2 is 0, minus 1 times 2 is minus 2, and that's 0. So this is your new table to draw a graph of y equal to 2 sine x. Awesome. Let's do that. That's suppose 0, that's suppose pi over 2, and that's over pi, and that's over 3 pi over 2, you can say, and that's over 2 pi, you can say. All right, suppose that's over 1, and suppose then that's over 2, right? Suppose that's over minus 1, and suppose that is over minus 2. All right, let's use this table and mark the points here. It's super easy. X is 0, y is 0, x is 90 degree. We got y2. That's why amplitude is increased, right? So when it is 180 means pi, so it is again 0. When it's 270, it is minus 2. So there is the difference. And then 2 pi again 0. And now you mark, join them together. There you go. So that is the graph of y equal to 2 sine x. And if you want to overlap both graphs y equal to 2 sine x and y equal to sine x, let's do that together. So we know for that table, which is y equal to sine x, let's mark the points. When x is 0, y is 0. When x is 90 degree, it is 1. When it is 180 degree, it's 0. And then it's minus 1 and 0. So then see, so that is your graph of y equal to 1 sine x. So now you can clearly see amplitude of the graph is increased. See? Make sense? So this is a graph. Inner one is y equal to sine x. And the outer graph is y equal to 2 sine x. So that's how you can draw the graph of any trigonometric function whose amplitude is changing, but there is no change in phase and there is no change in period. Awesome job. And I will also show you from the graph, if you want to find out amplitude by the same formula, let's find that. So maximum value of this graph is 2, right? Subtract the minimum value of graph is minus 2, and then we have to divide that by 2, which means that is 2 plus 2, 4 over 2 is equal to 2. See? So amplitude is 2. So you can also, I also show you how to find the amplitude of a function from the graph itself. Awesome, awesome, very good. Yeah, so, all right. And in the next video, I will show you how to draw the trigonometric functions graph when there is a phase shift. So this is very important topics. You know, students struggles a lot on those topics, but this is the easiest way to do these ones, all right? Thanks for watching. See you soon. Bye. Have a wonderful day.